For the second part of 10.2, we are going to look at now fractions and radicals and how they work combined. Two facts for us to start off with. First of all, a nice fact. Just like with multiplication, we can distribute radical signs to both parts, the numerator and denominator of a fraction. So if we had the square root of a over b, we can simplify that as the square root of a divided by the square root of b, which is very nice to use. However, the main fact for today is that proper simplification of a fraction means there's no radicals in the denominator. This is called rationalizing the denominator, where we just want that whole number or an integer in the bottom of the fraction. Let's look at how this plays out. First question is, which expression is equivalent to the square root of 35 divided by 15? So to start with, we'll use our nice fact. We can distribute that radical sign both the top and the bottom. So we're left with 35, square root of 35, divided by the square root of 15. However, we can't leave the radical, that square root, in the bottom of our fraction. So we have to rationalize our denominator. To do this is actually fairly simple in this case. We're going to use a little trick. We're going to multiply by 1. Remember doing this. And to get rid of my radical sign, I'm just going to multiply by the same radical. So I multiply the top and the bottom by root 15. I'm again multiplying fractions, which means I have to multiply my top and then multiply my denominators together, and that would simplify it. So let's look at the bottom first, because that's what we're kind of concerned about. Root 15 times root 15 is root 15 squared, and the square of a square root would just be the number inside of it. So very, very nicely, as we were hoping, root 15 times root 15 is just 15. You could also multiply inside, get 225. The square root of 225 is 15. It works out well. The top, however, we're going to have to multiply 35 times 15, and that would be 525. And so you'll note here that C is a possibility. Are there any others? Well, let's take a look at, can we simplify the square root of 525? And that, of course, would be yes, because 25 goes into 525. And so this would be equivalent to the square root of 25 times 21 all over 15. Square root of 25 is 5, so that is equal to 5 root 21 over 15. And if we wanted to, we could actually simplify this even more. You'll notice A is an option. But we have 5 divided by 15, which is the same as 1/3. So this is actually also equal to just 1 root 21 over 3, or just root 21 over 3. And so B is also an option. Actually, so the only one that's not equivalent in this case is D. So that's the process of simplifying. Let's look at one more type of problem we'll see. And that is when, instead of just having one radical on the bottom, we have a binomial, or we have two terms added or subtracted together. To take care of this situation, we're going to use another nice fact, which is called a conjugate. Now, conjugates are very, very similar to reciprocals, in that you can multiply them together, and they, in the case of reciprocals, get to 1. In the case of conjugates, they'll eliminate the radicals we're trying to get rid of. So what a conjugate is very simply, if I have 5 plus root 2, which I have in this case, the conjugate would be 5 minus root 2. Or if I had 5 minus root 2, the conjugate would be 5 plus root 2. All I'm doing is I'm changing that addition or subtraction sign to the opposite. So what I can do now, instead of multiplying by 5 root 2 or just root 2, which will end up not helping me at all, I'm going to multiply by the conjugate of the denominator, which is 5 minus root 2. So let's take a look at what happens. The first thing is, put my parentheses in there so we know we're multiplying. The top, my numerator, I'm going to be distributing this 3 to the 5 and the negative root 2. So I'm going to have 15 minus 3 root 2. That's my numerator. Denominator gets a little trickier. I have two binomials I'm multiplying together. If you remember back from chapter 9, we're going to have to FOIL these or multiply them together. So I'll start with my first terms. 5 times 5 is 25. 5 times a negative root 2 is a negative 5 root 2. Move on to my second term. Positive root 2 times 5 is going to be a positive 5 root 2. And then root 2 times negative root 2 is going to be a negative root 4. Again, if I'm multiplying square roots together, I'll just multiply the terms inside. Here's the nice thing about conjugates. You'll notice I have a negative 5 root 2 and a positive 5 root 2. If I add those together, that becomes 0. So I'm left with, on the top again, 15 minus 3 root 2 over 25 minus root 4, and root 4 is 2, so that'd be 25 minus 2. And then to just clean things up a little more, I can do 25 minus 2, which is 23, so just erase that down there, and write 23. So that is my simplified form. I got all of my radicals out of the denominator.